Hi, in this video I'll be explaining the first law of thermodynamics in under 4 minutes. This animation is just to get you a feel of gases expanding in a cylinder and moving the piston to and fro. Essentially what's happening inside a cylinder is that the gas has billions of molecules which all have kinetic energy, and these molecules are colliding against the walls of that cylinder and also against the face of that piston which is in contact with the gas. You can see a green piston. The cylinder is assumed to be very rigid and very strong. So if the energy of the gas increases, it can push against the piston and only one thing will move. That's the piston, because the cylinder and the walls can't move. Let's give some energy to the gas and see what happens. Now we are giving heat energy to the gas, delta Q, and the gas is doing work and is pushing against the piston and moved it out. It's doing positive work on the piston. A third thing is happening. The remaining energy is increasing the internal energy of the gas, and this is referred to as delta U and not as delta E. Let's take a relook. We give an input to the gas gives an output in two directions, increase in work and increase in its internal energy. So to get the signs right, the first law of thermodynamics is quite simple. There are just three things in it, and we have to get the positive and negative signs right. Delta Q is positive when we give heat energy to the gas. Delta W is positive when the gas does work on the piston. Delta U is positive when its internal energy increases. That sounds logical, and that's all there is to it. An easy way to remember is if you give some money to the gas gives some part of that money to the piston and keeps the rest of it in its own pocket. Well, if that helps, I'm okay with that. A numerical example will help in understanding it. So there is a gas in a cylinder. We give 500 calories of heat energy to the gas. The gas in turn takes that and does 490 joules of work by moving a piston. It expands and moves the piston. So the problem is find the increase in its internal energy. So it's just arithmetic. So delta Q is 2090 joules, delta W is 490. So the remaining part is the increase in internal energy, so it must be 2090 minus 490, that's 1600. I hope this was useful to you. Thank you. Bye-bye.